Our journey starts at the harbour, positioned close to the Great Pyramid Quarry. Each block is prepared for its voyage to the summit of the Giza Pyramid construction site by attaching floats. These floats, made of inflated animal skins and stomachs, are held securely in place using ropes and reed matting. Flood season arrives, and the water rises to fill the harbour and canal system. The blocks, all prepared with floats, are surrounded by water. As the height of the Nile begins to reach above them, the blocks begin to rise. From here, in 3s and 4s, the blocks are guided down the canal to the Causeway Harbour using cattle oxen. The next stage is where the benefits of Chris's unique system for raising blocks to a higher level comes into play. The causeway that leads from the canal to the pyramid precinct is essentially a massive pipe or culvert that seals in hundreds of gallons of water. Holding the water in place are 2 locks, one located at the harbour and the second at the halfway point where the causeway changes direction. The blocks are guided into the open lock, a few at a time until it is fully loaded, and then the first gate is closed behind them. The second gate is opened, and the floating blocks gently glide up the sealed and water-filled causeway. The second lock reduces the load on the lower gates from the many tons of water. The blocks arrive at the top of the causeway, straight into the pyramid precinct. Each set in turn would then be delivered to the different shafts on each side of the pyramid by workers using reed boats. On each side of the pyramid, water-filled shafts extend up to the work area. As with the causeway, it starts with a sealed lock where the blocks are guided in. The second gate is opened. The blocks gently rise out of the lock and float steadily upwards, letting physics and nature do all of the heavy work. This simple process cuts out thousands of man-hours of building gigantic ramps and dragging massive and extremely heavy lumps of rock around with ropes and brute force alone. At the top of the shaft, the gate is opened, and the blocks float into the upper channel, which is also flooded with water. A series of watertight gates are positioned around the upper channel to allow sections to be drained as needed. The smooth facing blocks, floated across the Nile from the quarry at Tura, are the first to be guided into their approximate positions. The outer gate is raised slightly, letting the small section of water drain away and the blocks sink onto the ground along with it. Then, the facing blocks are manually barred into their final resting place using mud as a lubricant. When a section of facing blocks has been completed, the channel wall is extended on top of them. and is once again flooded, ready for the interior blocks to be floated into place. Another huge problem that the flotation theory solves is that of turning corners. In water, they can be easily guided, even in tight spaces. And they're guided into place using the water-filled channel maintained at the top of the pyramid construction site. Reusable floats are removed gradually. The sinking block is guided gracefully into its desired position. This process being repeated around the pyramid and at each level. Using this technique, the ancient Egyptians could have built Khufu and many of its massive structures without the need for vast workforces. But more importantly, with relative ease, using something they had in abundance: water. Now read the book to give you a detailed understanding of the idea and the concepts behind it.